Hi everyone, welcome to the Tallinn Product Group podcast. My name is Nick, and today we're joined by Maksim Butsenko. Maksim is a staff machine learning engineer at Bolt. He started working there roughly 6 years ago, right around when data science as a function started at Bolt. He has worked on many interesting projects, such can include real-time pricing, user incentives, growth portfolio optimization, all using different machine learning data science models. Recently, he started working on customer service automation through using different traditional machine learning techniques, but also using modern LLMs. I really wanted to make this episode because it was interesting to me how the machine learning or data science teams work together with product managers, how product managers can be useful to machine learning or data science teams, how this cooperation even works, what are the challenges, the problems, difficulties, especially since machine learning is more like research heavy rather than traditional software engineering product management. So thank you, Maksim, for joining this episode. Thank you guys for listening. Make sure to subscribe to Tallinn Product Group Substack not to miss our new episode or posts. Thank you, and let's begin. Maksim, thank you for joining. Glad to have you here because I want to talk to you about machine learning, AI, all this fun stuff, and especially from the perspective of product management. Could you probably tell about Bolt and maybe, about the structure of your team?
Sure. First of all, thanks a lot for inviting me. Very, very exciting opportunity. I don't think I need to talk much about Bolt. I think a lot of people are familiar with this. So we are like one of the biggest European tech companies, still based in Europe, right? And I think a lot of people are familiar with the services, from ride hailing to delivery to car rental. So not much to describe there. On my end, I joined Bolt now a bit over 6 years ago, and at that time I was considering different position. I was just finishing my PhD, and I decided that I wouldn't be continuing in academia. So I was looking at different options, and Bolt at that time, Taxify, was one of the options. And there's a funny story about that because I was applying, and then I got the news that one of the data scientists that I knew got signed up by Taxify, and I was like, okay, they already got the data scientists. Like, how many data scientists they actually need? But I still proceed with my application, got on the team, and now we have over 40 data scientists, and we are hiring, I think, 10 more this year. So just to give you the sense of scale, how we changed in 6 years. So yeah, that's my story after that. Been involved for over 6 years, did different things as I was one of the first team members, then got to see how the whole data organization and machine learning and data science team grew, from starting from scratch when we kind of trying to figure out how to deploy the first models, now to basically working with very, very, very complex projects.
Mm-hmm. And you're saying it's like 40 people, 40 data science people at the moment in your team?
Yeah.
Is it in just your team or is it in the company at all? How is everything structured?
Yeah, let me try to put the puzzle together. Over 40 people that are purely, let's say, data scientists, are like data scientists, machine learning engineers. We kind of stack them together, depending on the domain people are working with, but let's say it's same type of profile of people. Together with that, we're also having data engineers and data analysts who perform different type of jobs, obviously. Initially, when the team was started, then we had a sort of central approach to kind of data science team. So there was one central data science team with people responsible for different domains and different areas of expertise. But it has changed to time. So right now, let's say those 40 people, they are organized in different sub-teams, which are placed in different parts of organization. But those are basically people who work on data science projects, work on different machine learning models, things like that. Together with that, we also have a machine learning platform team. People there, we refer to them like data engineers. In a lot of companies, they will be referred as machine learning ops engineers. So those are also people who support us with building the machine learning platform where we can actually very, very conveniently and reliably deploy our models to productions. So instead of this taking I don't know, days of work. I mean, for us, it's made so easy by this team. So it's kind of like we can take, let's say, prototype from the Jupyter Notebook, which is the usual tool that data scientists like work with for prototyping, and take, let's say, the model in production maybe like in a day or two, right? So you just can very, very conveniently deploy things. And then obviously a lot of work is getting supported by a data analyst and a close collaboration with them.
And before this podcast, I actually had a big problem. I didn't know how to call you, your position, and your team. I had a couple of ideas like machine learning team, data science team, AI team, LLM team. Could you say like what is wrong here? And could you walk us through this terminology?
Yeah, I think I wouldn't kind of like cover the terminology that much, but maybe kind of describe the journey at Bolt of how, let's say, this notion of data science team and people working on data science and machine learning projects have changed through time. So initially, when we started, as I said, we kind of had this sort of central team for how data science projects were managed. And if you maybe think broadly, there are kind of three types of like organizational scenarios how you can organize such type of team. First is kind of like this central approach, right? When you have kind of like everybody is in one team, and teams who need support of data science and machine learning engineers would come to this team, pitch the project, and then you can go project by project basis. The second approach would be like completely decentralized, where like you would have data science or machine learning engineer embedded in each of product teams, and they work completely like in a cross-functional team. And the third approach, and that's the approach that Bolt had when we started, so like 6 years ago, is kind of this sort of hybrid approach where we mix both the central, so we call it like center of excellence, right, where all the data scientists report in the same line, but everybody is working on their specific domain. And what it got us in the beginning is that data scientists could very easily collaborate between each other, kind of share the ideas, share the methodologies, especially in the first steps when we actually were building the infrastructure and even kind of understanding about business problems. That was very crucial for us. But at the same time, kind of each of the data scientists was deeply embedded into the particular product domain that they were responsible for, kind of building this expertise on how to support the business in the best way. So we called it at that time the hybrid approach. But as organization grew, and that like, just to give you a scale, right? I mean, it's like during this time, Bolt grew over like 10 times. So when I started, we maybe had around 45, 50 engineers. Right now, it's like, I don't know, somewhere between 500 and 1,000. I don't know even exact number because like there are so many people joining like each month. So right now, the nature of the team has changed so much that each of the data science teams are actually embedded into the product team itself. So like we completely reorganized data science teams, made the structure completely decentralized. So each of the data science sub teams work closely with the product domain. So you can call us like basically cross-functional teams right now. So in a sense, my team is not called the data science team or machine learning team or AI team. It's actually part of tools and workflows team, which is the team in Bolt, which is responsible for customer support interactions, right? So we are embedded into this product team, and that's true for every other data science and machine learning sub team.
You basically got rid of this data science as a function and completely devoted. Each and every product team has a separate data science team.
Exactly.
And then there is a machine learning platform, which enables all these deploys, features go to production, all thanks to machine learning platforms.
Exactly. And it's like very easy to visualize if you think like, let's say, like 2 years ago, all the data scientists were reporting centrally into one head of data science. Right now, each of the data science subteams will report into the engineering manager inside each of the product teams. So we kind of like part of kind of this engineering subteams, let's say, right?
Okay.
And then, yes, there's kind of separate platform team, which deals with the kind of this machine learning platform that each data science or machine learning subteam will use.
Okay. Then maybe it's good moment. Can you explain how product manager is positioned in all of this? Like you say, there's engineer manager, there's data science team, but how does a product manager work?
Yeah. So the product manager will be kind of like this parallel type of organization for us, right? So it's kind of like they will report into different units, but product manager in a sense is the captain of the ship, right? So for us, let's say we can think of each of the product manager as like this CEO of this particular team or particular kind of project they're leading. So they are responsible kind of for everything that happens. And I think like this captain is a good analogy because kind of their job is to kind of maintain ship on the course. And it's very clearly defined kind of what is expected from the team, what sort of metrics we're optimizing or what sort of KPIs we're tracking kind of. And their goal is kind of to lead the team into the direction of kind of improvement, right? It might be kind of like by correcting the course, by removing obstacles, so kind of like just making sure that team is delivering, right? An engineering manager kind of on their end will kind of ensure that all the ship, like all the necessary parts of the ship work as expected. So, and depending on the team, the distribution of, let's say, software engineers and like I said, data science, machine learning might be different, right? In some teams, let's say it might be like very backend heavy, and there will be like more like a classical software engineers. For some teams, they might be more mature and the projects might rely more on, say, machine learning and data science-based approach. There we might have like a higher ratio of data scientists, machine learning engineers. So kind of that is like team dependent.
And can you maybe list some teams or maybe some product features or basically in which product features do you need those machine learning skills or data science skills? I still don't know how to properly call it, by the way.
I think a data science machine learning is good umbrella term that we can use. Like I personally try to refrain from using term AI or kind of artificial intelligence. It's a bit too broad and different people put different things into this. So very hard to say like what are they actually talking about. So I would usually try to be more specific. And I think in terms of kind of what are the features where data science is present, it's like very easy to visualize if you think about kind of like Bolt app and things you can do there, right? So let's say when you order a taxi, like we usually show you like when is the time the taxi will arrive. So like this ETA or estimated time of arrival, right? And to calculate this time, we obviously use machine learning models. So we kind of try to understand kind of what is the path that the driver will take, like, and how long it will take considering the current time, the current traffic, so things like that. Then, for example, if you would like to use our car rental service, right, then you need to upload your driving license. And there we have to check if it's actually a real document, if it's yours document, right? So kind of things like that we also do like through the use of the computer vision models, like on our end. Then we can consider,
Sorry, don't you use some third-party solution for this?
We use both. We use third-party solution as well as in-house built things. So that's the thing for most of the work that we do. Bolt is a very pragmatic company in a sense that our job is kind of to optimize the service for our users, and that's usually for the things that we do. There are two main things that users care about, right? It's kind of like price and time, right? So like how quickly can you get a cab, right? And how much it costs. So for us, kind of this optimization of operation expenses is very important. So if we can do better job than external models, makes sense to go in-house. If there's like say no competence or not enough scale for us kind of to deploy the things on our end, we gladly use some third-party solution until we kind of grow business enough like to make sense for us like cost-wise to do it ourselves. So we are very pragmatic in a sense like how to mix those approaches.
So you listed verification, identity verification. You listed also ETAs, calculating ETAs with machine learning. Maybe three more.
I think let's switch to the scooters, right? So in scooter micromobility business, like the things we do there is very nice things like the stand detection, right? So like in a lot of markets, it's forbidden to ride on scooters like with two people, right? Like I mean, there should be one person riding on a scooter. And now the question is like, how do you detect that there's like two light person on the scooter or one heavy person, right? I mean, like weight-wise, there will be the same. So again, kind of that's the work that our awesome rentals data science team is doing, kind of like detecting kind of what like how many people actually like riding on a scooter. But then we have things in our delivery team, which is pretty awesome. Again, I would mention this estimated time of arrival, but just to kind of explain the complexity, if you think about like ride hailing, then it's considerably easier to calculate the time of arrival of a taxi because it's kind of taxi and it goes from point A to point B. But if you consider kind of like when you need to order food, what happens? You place an order to the restaurant, right? Restaurant have to prepare the food. Courier has to arrive to restaurant. They have to pick up the food, and then they have to go from the restaurant to your place, right? And then we need to understand when we need to give a signal to the courier so they would go to restaurant, because if we give the signal too soon, they will just like wait there, right? I mean, no point. If we give the signal too late, the food will be cold. So kind of the third party kind of marketplace that happens in the delivery business side makes everything much more complex. But on the other end, much more interesting as well.
That's actually interesting how it works. It's actually interesting how it works. Like, do you do any estimate? Like, how do you even? Okay, maybe this is a little bit off topic of the podcast, but
yeah,
maybe in 2 minutes.
Let's leave to the listeners to figure out like how to even start approaching such type of problems. It's nice brain exercise.
Okay, so there are many teams within the Bolt that use machine learning, and it's interesting what are the differences between product teams that have machine learning and product teams that don't have machine learning. Like, what are the differences in product management approach to this product?
I think it's a good question. For me, it may be like maybe a bit difficult to explain because obviously I'm very biased towards kind of the teams where I'm being involved. I'm being involved in the teams where we have kind of data science and machine learning based approaches. How we usually think about kind of this progression or kind of like when to even kind of bring data scientists on board is like if you think about it, then for a lot of things, some heuristic-based approach that you can code up in the backend, let's say, I mean, you need to produce some number. Let's take an average of whatever we have in statistics. Like, I mean, not everything needs to be solved through like fancy machine learning projects. But at some point, your business starts to grow. You get more customers, revenue starts to grow, and you understand kind of, okay, there are a lot of cases where this like average number is not enough. And I think, okay, if we do a bit more sophisticated logic, then we can provide a better service for the user, right? So maybe instead of kind of producing the average number, you will say, okay, in this time, take average, in this time, take, I don't know, 19th percentile. For this time, take average and calculate those 2 minutes. So you start building heuristics on top, right? Then at some point, just managing those heuristics becomes very difficult. Somebody needs to update them, like not really clear how they work. I mean, is it even kind of the best combination of heuristic? Maybe there's a better way. And that's a good time, like when you start bringing, let's say, data science and machine learning, like data-based approaches, right? So kind of there are some methods like where you can learn from the data what is the best combination of those kind of, say, rules, right? So now your team a bit like has matured a bit. Like now you're not only having like software engineers, but you start to bring data analysts, data scientists, machine learning engineers on board. So kind of team structure starts to change. So let's say we think about it as like this natural progression. So like for most of the things, you start like very simple, and then as your business and like team grows, like then you start to go like more complex approaches, right? But in a lot of cases, for a lot of businesses, like this heuristic-based approach is completely enough, right? And then there is kind of this next level. Let's say after you brought, like, let's say, machine learning engineers or like data science-based approaches, you can be even more complex there, right? A lot of for a lot of companies, kind of this first machine learning model that you built will be completely enough, kind of to cover, let's say, most of the cases, right? And the more complex you want to go, the more difficult it is kind of to come up with the solutions, to maintain them. So again, kind of, your business has to be the size of a very big companies, kind of to talk about very complex models, let's say. So I would maybe kind of like put kind of this rough line. Let's say if you start, let's say if you're already kind of on a unicorn level, right? Like maybe like revenues like in hundreds of millions, then it's like starts to make sense to bring, say, data-based, machine learning-based specialists to the projects that you're doing. But if you want to kind of use state-of-the-art approaches, then most likely you're already kind of like maybe not Google size, but let's say it's like billions in terms of revenue, where you do actually very kind of fancy stuff.
Mm-hmm. It's interesting that from your answer, I picked this thing, like, am I correct? If I'm a huge company, let's say I'm an old bank that, I'm an old bank, or I'm a big old company, corporation, and I probably don't use machine learning or something very sophisticated, but I plan to. Does it mean that I don't need to run and hire the whole data science team as soon as possible? Does it mean that I should do step by step, small steps, and only once I'm mature enough, once I have many, many models to manage many products with machine learning in them, only then I need to think, how do I structure my data science team? How do I structure my, I don't know, product management? How do I shift it more to research-based product management?
Absolutely. I think if you Google something like data hierarchy of needs or something like that, there is like a lot of images in the internet which show the pyramid, right? And it will be kind of the basis, kind of get your data right? So kind of like this data layer, good structures in the database. You're able to run like very simple kind of, not simple, but let's say the basic business analysis on kind of the things that you do kind of like conveniently, right? Not kind of there is kind of some data dump, like you import it in Google Sheets and somebody kind of does something like on that ad hoc level. Get this right? After that, you bring like data analysts, which start building kind of very, very nice dashboards, everything automated. Maybe they start kind of with very simple, let's say linear regression type models, right? And maybe that's enough for the business of your size. And then maybe in the end, right, when you're like really, really big, then you start kind of bringing like machine learning engineers and kind of people to build really, really sophisticated things. Because each of this level, I mean, it will, let's say in the first level, you solve 80% of your problems, right? Then 20% remains. You bring data analysts on board. Out of those 20%, they solve 80%, 20% remains, right? And to solve this 20%, okay, now it's 20% of 20%, right? So like very small amount. So your business has to be like really big for you to optimize this with bringing specialists who demand really high salaries in the current market. So kind of it's in the end it's like very simple kind of trade-off. Like you're able to calculate like how much you can improve, what it costs.
Mm-hmm. Yeah, so it's about big companies. And now I start thinking about this startups that raise millions or billions of dollars that are AI, ML based and everything. It's interesting, how does it work for them? Do they have to run quickly to this, let's hire machine learning team, let's hire data science team, let's do all this stuff? Yeah.
I think it's different way of kind of running the companies, right? I mean, maybe if you want to inflate your valuation, kind of like just raise another round and another round and another round, then obviously you should build kind of on the hype and kind of like build on the things that will attract investors, right? It doesn't always mean to be kind of the product and like high revenue, right? But if we're talking about kind of some sustainable business, then you have to be really conscious about kind of your ROI choices, kind of, and where do you invest those much money. Again, and also like we I think like talk about more conventional companies. Like obviously there are companies for whom this like not don't want to use the term AI, but let's say machine learning based things is kind of the core of their product. Like, and that's kind of the basic like what they're selling. And for them, obviously, kind of starting with the core machine learning team makes a lot of sense because like that's the product they are building, right? So okay, like OpenAI, I mean, they started building things around kind of this machine learning and very sophisticated models. So for them, that was the business. But there's only a handful of companies kind of who do this, and even less companies who do this in a financially reasonable way.
Mm-hmm. Yeah, just to sum it up, if you're a big company and you think to introduce data science or machine learning, start small, think about your data, clean your data, make sure it's easy to build reports, to do basic data analysis. And then at some point you might think about data science, machine learning, etc., etc. Solve
Absolutely.
your 80% and then solve 20%.
Yeah.
And if you are...
Sorry to interrupt. Hire data engineers first, then hire data analysts, then data scientists.
Yeah. And if you're a machine learning, data science, AI startup, then good luck. You're in a different game. Just you either know what you do already or just hire a machine learning team and make it your core. Nice. And if we move on to this product management, I want to ask, how does a product manager work with a data science team or ML team? Like, how would it work actually technically? Would I come to you and be like, hey guys, here's a feature, here's an idea. Can we build it quickly? Can we ship it? Can we test it? How would it work?
Yeah. Here, maybe kind of to add a bit in the context, like how it worked at Bolt, is that we actually started scaling our data science team before we even have had any kind of product managers on top. So we didn't have dedicated product managers before we started kind of bringing data scientists. I mean, maybe not the thing that you want to implement on your end, but kind of that's how it happened at Bolt. And our managers were actually kind of our like top stakeholder. I remember still meetings like when Marcus would come and kind of start looking at the graphs that we produced and kind of asking questions for which we didn't have any answers, but we tried to find it like the next for the next meeting, and then we started hiring kind of like the product team. So I think what it got us is that our data scientists had to be their own kind of like let's say product managers, and kind of had to be very concentrated on the what is the value of the things that we build for the business. So we should kind of think first about kind of the product value that we create, and not about kind of are we using the most latest and the most exciting approaches, right? And that I think kind of helped us to build this culture in our organization where the new people that we brought on board, like we heavily kind of push them towards this way of thinking. So in a way, each data scientist carries this kind of like small like product manager hat on their head, and our partnership then with product managers are very natural because we can both discuss the things that we want to solve with them, we can listen to their feedback, but we can also like we can suggest what are the things that we should do because we also have access to data. So it's like for us it's very easy to validate ideas. Okay, like we see that for this particular case we lose a lot of revenue, let's try to solve it. So in a sense for us it's kind of very natural two-way communication with product manager. And as I was describing before, like how we think about when to bring machine learning projects on board, the team is already there, a team is solving already some problem, but the problem has become like so big, then it makes sense to start kind of looking at machine learning based approaches. So in a sense, kind of this discussion or those projects, they arise quite naturally, right? So it might be right that we had heuristics and now we want to make them more accurate, or the thing that we discussed, right? Like we used some third-party tool in order to solve this problem before, but our cost of using this part is so big that it makes sense to dedicate 2-3 people working on solving this internally, so we can use an internal service provider for, let's say, selfie verification or for ETA prediction and things like that. And then it's kind of very simple cost exercise, right? I mean, should you use the endpoint, external endpoint or internal endpoint, right?
So, and does it mean that if I'm a product manager, I would come straight to you as a data scientist? I would go to you and, hey, here's an insight that we found. If we improve it, we would improve our metrics by 15%. Can you go and test it? Or
yeah, if it only would be that easy. As I said, kind of like for us, we are heavily embedded into the product team. So in a sense, kind of there's no like product manager coming to us because like we are part of the team, right? We participate in those weekly meetings or daily stand-ups if there are any for the team, right? So we're heavily embedded into kind of how the team works. So it's like those topics, they arise naturally, right? So like we know that the team tries to optimize this metric. We know where we see the drop. So this discussion arises very naturally. How and why should we solve things? And like, what are the approaches? Should we still go with heuristic, or should we try to employ some machine learning or data science based approach there? And in a lot of cases, kind of it's data scientists who comes to product managers saying like, okay, look at this plot. It shows us like that in this particular spot, we're really kind of like losing, let's say, our estimated time of arrival for the evening rides is really bad. Like, I mean, we should do something about it.
Mm-hmm. Since data scientists are also wear this product manager hat, how do you then draw the line where here's a product manager's area and here's data scientist area? Like basically, where would be this line? What product manager does and what data scientist does?
in my mind, I would still kind of use this analogy of kind of the ship, right? And like product manager is the captain of the ship. And if everything runs smoothly, I mean, they don't need to be involved. I mean, they see that the team is going into the correct course, right? I mean, if data scientists are working on impactful things, they solve impactful problem. I mean, they don't even need to get involved. I mean, they just like come like thumbs up. I mean, great job, guys, right? So that kind of ideal scenario, and like and sometimes work like that, right? But in some cases, kind of they need to be involved in a sense. Okay, we discussed this, but your project or your model is actually improving something different, right? Or the project takes longer than expected, or we need to pivot completely because our business priorities changed, right? So kind of this, they kind of this interface to the wider organization to understand kind of what are the priorities for our particular team, what are the priorities for organization, and do we need to make any adjustments? So kind of this notion of kind of like keeping hand on the pulse and course correcting when and if needed, and also kind of like propagating the work that team does upper in the chain, right? Kind of like explain to like higher up stakeholders higher up what is the team up to, how our priorities this quarter, next quarter, kind of help to prioritize between the different teams. So kind of that's their job as like job of the captain of the team. But ideally, kind of for those kind of small daily things, we expect our people to be able to fully kind of like own the project. Like they don't need to go and ask product manager feedback for every particular decision that we make. I mean, like for that we try to hire people who are able to do it themselves.
Mm-hmm. So then, would it be fair to say that you expect from a product manager clear priorities for the next, I don't know, quarter, half a year, maybe next year? What's the vision? Where do we go? Maybe also some insights, ideas. Here's what we can improve. So maybe we can work on this thing.
Yep, for sure. To add to that, also kind of we are changing a bit kind of the approach to kind of how we do planning. So like classically, we have been kind of using a lot of this kind of quarterly based planning, but I think we are now moving more towards kind of this continuous reprioritization. So if we see that something needs to be solved right now, right? I mean, we don't need to wait for quarterly planning to kind of like shift the plans. I mean, we just say like, okay, it doesn't make sense anymore to work on this project because, I don't know, for example, we wanted to launch in particular market, but we didn't get the license, right? Or simply some regulative thing that we need to solve, right? So kind of trying to do it like more continuously, that's where this collaboration with product managers is like really crucial. We expect them kind of like to be able to lead the ship in the correct direction, as well as kind of removing all the blockers, right? So let's say in the big companies such as Bolt is right now, there are a lot of teams that have to be collaborating between each other, right? So let's say like we depend a lot of, for example, input from the billing team, right? I mean, like, okay, what is the money that we were supposed to pay out for the users, right? So, but maybe their endpoint has some parameters like we want to change, right? But it's not priority for them, it's priority for us. How do you figure those things out? Like how do you communicate with separate teams? So kind of removing the blockers. That also kind of will we expect like a lot of like product manager to jump in as kind of like main stakeholder of the team, kind of to help to figure out our kind of priorities between the team if needed, because it's often very difficult, let's say, for the individual contributor kind of to solve it in a, let's say, the fast manner.
Could you introduce what your team does a bit more in detail? Maybe how it is structured and what are the things that you worked on recently?
So our team is called like Tools and Workflows, which is a bit generic name, so it doesn't tell you much. But let's say main things that we do is everything around customer support. And we are structured into the three teams. So there's Beehive team, there's support automation team, and there's support experience team. I will start with Beehive because it doesn't tell anybody anything. But I think a lot of people might know about the company called Zendesk. So they are the company who offer kind of this customer support platform, right? I mean, like it's like backend for your agents, it's kind of front end for your customers, so things like that. We were a very big customer of Zendesk, but when we tried to negotiate the price for the new contract renewal, they weren't very flexible. So we said like, okay, I mean, you guys want to play like that? Like we build our own platform. That's what we did. I mean, we replaced the Zendesk completely, I think, in a year. So build our own platform for customer support agents to do the backend work, as well as kind of all the integration necessary for the customer support application to work for the end users. And that's kind of basically the Beehive team. Like what they do is kind of they do this platform for the customer support agents. And then support experience team, they focus on kind of experience of support for our end users, right? So when you open the app, so it's kind of very natural for you kind of like, so you would know how to write us a message and explain your problem. There's very easy access to report your issue. Kind of everything's is nicely supported. And then third team is the team I think that we as like why I as a machine learning engineer collaborate the most is kind of support automation. And this team is responsible for making sure that we can offer high quality support at the very fast time, right? I mean, so like, let's say if users write us a message, we try to solve the issue as fast as possible, and it usually means in an automated way, right? So initially we started, as we discussed previously, kind of with heuristic-based approach, where we kind of like had this automated rule-based system. Let's say if you had the order related to ride hailing, and then your order payment method was cart, and then in your message there were certain keywords, we would say, okay, we probably should give you a refund. So things like that. But now, obviously, we are transitioning a lot to using large language models, both reasoning engines as well as reply engines. So kind of like when you write to us, kind of we try to understand what is the best way of solving your case, what sort of action would make you happy as a user, would help us like solve your case, as well as kind of like produce reply in like a more human style sounded like, and not kind of like to be like very robotic. So kind of that's the part where a lot of machine learning work goes in, and that kind of shows this nice transition. The team like starting from kind of like very simplistic, let's say, automations based on rules, going to machine learning models, going to large language models, to things like that. And so yeah, we have kind of like 3 dedicated sub teams, and I think we have 4 machine learning engineers kind of like supporting those teams with different types of projects.
Mm-hmm. What is the coolest thing that you recently released that everyone who uses Bolt support can actually see it and feel that that's what Maksim worked on?
Yeah, I think this Alfred bot. So like when you write the customer support messages, often your case is getting solved by our chatbot Alfred. So that's the thing that the team was working on for quite long time. There's still a lot of things to polish, and that's kind of the recent meetup that Bolt organized, where we kind of described the approach to this problem, as well as kind of the things that we know are not working that well yet, and we have the project to solve this. So retrieval augmented generation, right, kind of to produce more truthful replies for the customers. So that I think kind of like the biggest thing that we shipped recently.
And Alfred works with each and every case. So
No.
if I now go and message, it will reply me?
No, it wouldn't work for every case. There are kind of certain conditions where it wouldn't apply, but we try to utilize it in all of the cases where it's capable of supporting users. But there are kind of specific cases where it won't be getting involved. But obviously, as we improve it, we try to employ it in as many situations as is reasonable.
Yeah. So now, given all the context about you, about the product management, how all this is done. Before this podcast, we met at Bolt, and you gave a presentation about customer support, how you do automation, and you were talking, presenting, and I thought to myself, why do they even need product managers? Like, from the perspective that you basically do research, a lot of research, and basically a lot of your outcomes, basically a lot of things that you can do, it all depends on, hey, we will go and experiment with a RAG, we will go and fine tune the model, and only then we probably will see what we can do and what we cannot do. So for product manager, it might be a little bit difficult, like, hey guys, let's set as a priority this thing, and you come and say, yeah, sure, we'll go test, see, research for a couple of weeks, then we'll come back. Maybe we can do, maybe we cannot do, who knows? Let's see. So is it the false perception of what actually happens, or how does it actually work? So if you can explain, that would be amazing.
Yeah, I think you're touching on this point of how to lead research-heavy teams and kind of like how to work with teams whose work is like to research a lot of things, right? And it's really tricky because research is exactly as you said. It's kind of you don't know the path to success. You don't know, even know kind of like if it's possible to solve this thing. So in a sense, it's kind of this leap of faith that you are making. So you might consider that reward is big, but you always have this risk that you will spend I don't know month of time of kind of researching thing, but your thing that you will find that like it's not possible to do, or let's say it's possible to do but it's very expensive, or it's possible to do but let's say the metrics like the accuracy of the model that you're deploying will be only slightly better than the existing like heuristic based approaches that you have, and that's the risk that's always there. So kind of like it's the first thing is like to acknowledge it is there, and then just to think like how much of this risk you can take. And that worked. What worked for us, or what's working for us, I think, rather well, is every time kind of we start this sort of research project, it's always good kind of to like time box them, right? So in a sense, we considered, okay, let's investigate this particular method or this kind of like, let's say, research paper that claims that they do awesome thing, but let's say we spend 2 weeks on this, and we do kind of a lot of work like during these 2 weeks. Like we try to kind of estimate like to get the prototype working, like we'll cut corners if needed, but we want to do something so that after 2 weeks we have kind of understanding. Is it applicable? How much unknowns there are still? Like, can we measure already kind of like what will happen if we deploy it, right? So we need to have some information, and then we can reassess, right? Okay, we use 2 weeks time, we have nothing. Maybe it makes sense to drop it for now, right? Maybe some things are missing, or we made some progress. We still don't know what the result will be, but we know that if we spend 2 more weeks, then we can validate this, and this idea. And I think what helps a lot there, kind of to have this, to establish this kind of like the stakeholder trust, right? I mean, because it's basically like a nature of trust. So like product manager says, okay, we dedicate time to this research project. But if nothing, like, I mean, you do it once, you do it twice, you do it 3 times, right? If nothing happens, then obviously it's very easy to lose trust. So kind of this trust between kind of like the data scientists, machine learning engineers, and product managers is very important. And how it's getting built on our end is basically when we start with some project, we obviously do a lot of exploratory data analysis, right? We dig into data, we try to understand kind of, okay, what this data tells us about this particular problem, right? And sharing the results of this finding is very important because it already kind of starts painting the picture about the problem that you're solving. And sometimes kind of during this exploratory data analysis, you find actually that there are more relevant problems to solve than the thing that you're trying to solve in the first place. And you'll say, like, okay, but you know, it's actually it's not even a problem. I mean, the problem is actually something else. And kind of establishing this dialogue and sharing those findings right away, that's always kind of like the main output of this kind of research stage. Not the kind of final model, whatever kind of, but this process of kind of like exploring things, sharing with the team, receiving the feedback from the team. So it's always kind of like, let's say you do the first snapshot of your data analysis, you say, okay, I have kind of very nice findings here. You present it to the team and they have kind of tens of questions you don't have answers for. So like back to the drawing board, getting more data, like doing more plots, like trying to figure out how the things work. And that already kind of creates a lot of value. And I think kind of that's what our product managers often kind of see there, right? I mean, okay, maybe there is like no output of particular project, but we learned so much just by doing it. And that I think kind of like established this trust between researchers and product managers.
So, and let's say I'm product manager, I will come to you and say, hey, there's this project, would be nice if we can solve it with, I don't know, LLM, some ML model, something. Can you go and research it and do something? After 2 weeks, you come back and you say, hey, we figured out that this model doesn't work, this LLM doesn't work, this one wouldn't work, potentially this one would work, but we are 50% sure. So it kind of almost leaves a product manager in an interesting position where we cannot deliver anything or test anything Would it drive metric up or down? Would it improve something? We cannot do it basically until you are done with the research, or how does it work?
I understand what you mean. It's a bit more complex than that because we have a lot of projects going on at the same time, right? I mean, like the teams are considerably big, so like there is like usually not that much time waiting for kind of like data science to release something because there are a lot of other things to solve meanwhile, and we kind of try to also kind of like balance things in a way that kind of like some things are getting deployed, some things are kind of in research stage, so we kind of try to pace it in a way that kind of there is always something like going into production, so there's always something to work on. To add to that is that our data scientists are heavily involved already kind of in the planning process. So when we plan kind of like the future work, right? I mean, we already kind of discuss what is reasonable to focus on in the next quarter, in the next half a year, in the next like year, right? I mean, we can always kind of shuffle the priorities, but we have kind of we always try to maintain this backlog of projects that like, okay, those are the things that would be meaningful to solve, and then we can always kind of like reshuffle it based on, okay, the impact of this feature now will be bigger because some market condition changed. Okay, let's take it on top. Let's start working on this. So we actually don't want to be in a situation where, okay, we actually don't know what we want to do. We are depending on this data scientist to go figure out and tell us like what is the next thing that we work on. I mean, that's kind of like not what we want to do. So in a sense, we always want to work on something that we know will potentially move the metric. Obviously, and that's a different talk. Like, will it move the metric in the end, right? I mean, but at least we have those projects always kind of ongoing.
Yeah, and you touched on this topic of you're trying to work on something that actually moves the needle. And how do you understand, again, as a heavily research-based product, how do you understand what would move the needle and what wouldn't? And how do you maybe estimate the impact?
Mm-hmm. So obviously we kind of try to understand first kind of like from the first principles, like what are the things that are important for the business, right? So I think easiest would be explained like through the kind of ordering funnel, right? I mean, so when you open the screen and you want to order a taxi, kind of like what are the two things that you are the most focused on? So for example, in your case, like you open the apps, like what are the two things that you most focused on?
Well, I pick my location, where I am, where I want to go, how much it costs, yeah, the price, and what is the waiting time. Yeah, and also the time to location.
Yeah, like pretty obvious thing, and then it's like clearly for you kind of like how varying those variables will change kind of will you order or not, right? I mean, like, so if the price is like 2 times like the price the last time, I mean, most likely you will consider maybe I'll go with another app or kind of take the bus or walk or whatever. Or if the waiting time is like not 5 minutes but 30 minutes, I guess like your conversion starts to drop. I mean, very obvious things. So kind of this reasoning from first principles, kind of what is important for the business is kind of already kind of the first estimate. So you know that if you start improving this particular part of the funnel, most likely it will result in a good experience for the users and like maybe increasing the revenue. Then the next step for, let's say, for data scientists themselves is kind of to connect those kind of first principles to like things that business metrics that we're focused on, convert them to kind of like those machine learning metrics that we would try to improve, right? Let's say in the same scenario, we'll try to predict what is your conversion probability, right? And then we want to be like very accurate on that, right? So kind of that gives us kind of this lever. Okay, if we improve the model of predicting this probability and we probably like predict it like really, really well, probably we are like end up with a good model, right? So kind of that's kind of the next step where we kind of iterate and prototype, and then at some point we are happy with this, let's say, accuracy that this model produces. So we kind of discuss with the team, right? Okay, guys, we have this model. It does this with this accuracy. Let's deploy it. And when deployed, then we obviously want to A/B test it right now, right? So it's kind of like, okay, we have this hypothesis that by having this accurate model, we can improve this, let's say, conversion rate. But now we actually have to go in live and test if it actually does this. And that would be kind of, let's say, this kind of final validation that what we did actually is useful for business. So kind of this 3 steps, right? I mean, like arguing from the first principle, then connecting kind of those business metric to some metrics that data science and machine learning engineers can, let's say, work on offline, so they don't need kind of to go and test always on the user. But the endpoint is still like you always want to go and test it, kind of like how does it impact the actual behavior of the people? How does it actually improve the business metric in the end?
So if we bring it back to your team, then let's say the business metric is customer satisfaction. Then you would connect it to a metric first, like minutes to first response, like
For
how
example,
quickly we respond to users' message. And the third step was
and the third step, we deploy this model, and then we'll see kind of if this, let's say, chatbot, for example, it answers faster. If we are actually kind of users interact with this and it actually answers faster, does it actually lead to the higher customer support satisfaction or not?
And you kind of also have some estimate. Once you have the model, you have an estimate by how much it might increase. And that was one of the things I want to ask. Like at your presentation, you said something like, we plan to automate our customer support by like 4 times. And then someone asked you, like, how did you pick the number? And you basically showed in the sky, you picked a number, and then it was 4 times. So is it always like you estimate the impact in research-heavy products? Do you estimate by guesstimate?
Not always. For this particular scenario, right? So the context there was kind of we were discussing kind of the change from this rule-based automation to things where we used kind of large language models. And for us there, this like the release of, let's say, ChatGPT and GPT-4 made kind of this technological, like the moment of technological disruption. So like the things completely changed. So like we actually had this chatbot, which was very natural to converse on. It could logically reason. So it made sense kind of to consider kind of, is it really big improvement into like how people communicate with this type of chatbot? And at that point, kind of it seemed that like initial exploration, initial demos that we did with GPT were very awesome. So it's like, I mean, it could improve a lot. How much? I don't know, 4 times. 4 times. Everybody kind of seems like, okay, it's like, it's not very small numbers, like very, very big number. It's not kind of like 10 times, right? I mean, so it's not kind of absolutely like out of the blue. So like it seemed kind of more, let's say, more than we initially kind of planned for let's say conventional type of work. So for this particular situation where kind of this moment of technological disruption, I think those guesstimates is kind of the best you can do, right? So obviously you want to have people who have experience with technology. They see in kind of different kind of events how the things change. They kind of like their estimate probably will be a bit better than kind of like just person from the street, but still it's in the end it's a guesstimate.
Can you share some other improvements? Like, was it actually 4 times? Was it, maybe customer satisfaction maybe increased?
Yeah, so we expected, like, let's say, when we decided that we will now migrate to like using large language models and completely kind of revamp how we approach the customer support automation, we thought that like we could increase existing automation rate like 4 times. In reality, after a year of kind of like working on this, we increased it 2 times. So not exactly what we hoped, but still kind of like pretty nice results. And in terms of customer support satisfaction, let's say there we try to keep things like balanced. So it's very hard at the same time to optimize kind of, let's say, the automation rate, right? So improve how you handle the cases as well as customer support satisfaction. So kind of you have to focus kind of like on one metric first. So kind of like our plan is usually kind of that we fix kind of the things that we don't want to kind of to go down. So say setting like these guardrails, right? So like when I A/B test something, like you don't want kind of those things to go down. If it goes down, it means like something doing wrong. And then you can pick the metrics that you want to improve, right? And the next time around, let's say like we might focus, let's say, on the customer support satisfaction and say, okay, we want to leave automation rate stable. We don't want kind of to reduce it, but let's work on kind of how to improve customer satisfaction. What's important there, right? So kind of this trying to optimize one metric at a time usually work better for us.
Now that you switch to LLM, I assume OpenAI, do you see any improvements in costs? Or basically, how costly was it to develop this LLM at the first place? And now to support it, basically, does investment make sense?
Yeah, it made totally sense for us because we could improve the automation rate a lot. And Cost-wise, obviously, if it would cost more then we wouldn't do it. So let's say the calculation there is makes fully sense. And just maybe like kind of to give you kind of like a brief context kind of complexity of customer support at Bolt, why it makes a lot of sense is that first of all, we support a lot of kind of business verticals. So we discussed this already, kind of like micro mobility and delivery and ride hailing. And obviously this comes with the notion of kind of us operating in the real world, right? So it's not kind of like cloud-based software sales, right? I mean, there's actually real, like actual people moving in an actual world. There's actually the kitchen which prepares you your food, which I mean, like the equipment can go bad there. I mean, like it can break, right? So like the things that we have like no control over. So kind of we have to support all the scenarios, as well as Bolt operates in over 50 countries. So it means like regulation in each country might be different. So we have to support this, as well as kind of all the different languages. And so, for example, try to find the agent who can offer support in Norwegian language, right? Most likely they reside in Norway, right? And cost of living and therefore salaries in Norway are pretty expensive, right? So if you can run a system which can, let's say, translate your English support on the fly, like to Norwegian, I mean, you save a lot of costs on like purely kind of that you can replace, let's say, this more expensive workforce with like less expensive workforce, or with completely automated system. In a sense, kind of this cost-wise change like obviously makes sense, or like should make sense financially for you kind of to even consider kind of this.
Yeah, and it's basically the longer we talk about, the more I think about what we talked before about larger companies starting using it. And like first you solve first 80%, then another 80%, another 80%. The more I think that this whole machine learning, data science, it feels more like for teams, for companies where it actually makes sense to like financial sense, because the salary of researchers, then all these models, all the servers, infrastructure, all of this to support it, it must make some financial sense. Like you save more than you spend on these models. So yes, if you're a small business, maybe it doesn't make 100% sense for you to implement all these models.
Yeah, exactly. So in a sense, kind of, let's say, as we discussed before, if you can just kind of calculate your average sales and kind of use this number for your kind of predictions, maybe it's enough. But yeah, you can come up with more sophisticated model, and it will be 5 percentage point more accurate, right? Is 5 percentage point worth it for a small business? I mean, if your, I don't know, monthly revenue is like 20K, I mean, is it worth it?
Yeah, it's kind of like a big numbers game.
Yeah, exactly.
And there's this idea of running tests and testing your hypothesis. And especially with A/B testing, there's the more hypotheses we can test, the more times we can fail, the more successful we are, or something like that, this motto. Can you maybe share how many tests you run or something from this area?
We have a pretty sophisticated kind of A/B testing platform that we run inside Bolt. So we have dedicated experimentation team which supports it both infrastructurally as well as like methodologically. So kind of like trying to make A/B testing approachable to everybody, right? So it's not like kind of everybody has to go and invent kind of like how do I test this feature, right? So kind of it's everything automated, everything nicely calculated in statistically significant and correct way. So in a sense, we try to make this experimentation of hypothesis, like testing your hypothesis, as simple as possible, so people will always go and test where it's reasonable, right? Because kind of that's the best way of kind of understanding, does your feature actually improve the user experience? Does it actually kind of move the needle? In terms of number of tests, I think we run maybe hundreds a month. Like I think like the order of magnitude is like I think it's in hundreds. I would say it's not in thousands yet, but I think hundreds a month, or kind of tens, or like even maybe already 100 a week might be kind of like the order of magnitude that we do.
Do you mean, is it just for the whole Bolt, or is it just for your team?
For whole Bolt.
Whole Bolt.
Yeah.
Okay. And within your team, like how many times does my conversation with Bolt changes?
In our team, I think we do maybe several tests a week.
Okay.
But the testing very different, the different feature. It doesn't mean kind of like it's always kind of like what you kind of as a user will clearly identify. So it's a lot of things that we try kind of to test and release.
I have something about how difficult is it to come up with a solution, and what kind of challenges do you have while coming up with those solutions? How to prototype, how to test solutions. But we kind of touched it in some points. Do you think you have something to add about how difficult is it to come up with a solution? Because in my head, I have this idea that product manager comes to you. Like we agreed that you have daily stand-ups and weeklies, but let's imagine product manager has this, hey, we did some research. We figured out if we do this thing for that many users, then it can improve some metric, customer satisfaction by, I don't know, 1%. I don't know, something like that. And like in software engineering product management, it's relatively easy to come up with a solution. It's like we need a database. In database, we create the table. There we store this value. Then there's an API call every n seconds, blah, blah, blah. But with research-based, it's again, you time box 2 weeks and you go and sit in research. And then in the end of research, you either have the solution or you don't have.
I would maybe kind of try to challenge this idea that we go and find a solution. I think that's maybe kind of the big differentiation between how data science and machine learning engineers kind of approach their work and compared to maybe more classical way of doing software engineering, where exactly as you described, right? I mean, you have like pretty clearly defined steps and kind of things that should work, let's say, in 100% of time, right? I mean, if you write something to database, I mean, you expect that kind of every row you write, I mean, like it will end up in the database, right? I mean, that's what we do when we, let's say, do invoicing to the customers. I mean, we expect that every row will end up in the table, right? But if we think about kind of things that we as data scientists do, it's often that we can't give 100% guarantees, right? So kind of we do some model and it's accurate in some percent of the cases, and that's kind of the best guarantee that we can give. So let's take the same example of the selfie verification, right? I mean, we just can't guarantee that in 100% of the cases we will correctly identify a person in the picture, because some pictures may be blurry. For some pictures, maybe lighting is off, right? I mean, so kind of there are a lot of ways of how things can go wrong. So the best we usually do is that kind of we have some metric, like success metric, and then we say, okay, on this success metric, those are our results, right? Let's say 90% of accuracy, right? 95% of accuracy, 80% accuracy. So kind of that's the things that we usually kind of work with. And then it's very important to understand kind of if this type of results that we achieved during kind of this research stage, is it useful already or not, right? I mean, should we go back to the drawing board and maybe try to different modeling approach, try different type of library, maybe reconsider kind of like what sort of approach we should like take, or it's already kind of enough to move the needle in a meaningful way and to improve the user experience, let's say, right? So that I would say kind of like differentiating factor between how the classical software engineering is done and kind of like, let's say, data science, machine learning. But to add to that, kind of I think the thought that I had around kind of like how to also kind of think about this complexity of research is that it's very hard to be on a bleeding edge of research, right? In a sense, if you know that somebody already did it, right? They succeeded at something, it's very easy to go and try to replicate it because you know it's possible. But if you're on a bleeding edge, it's like if nobody has done it, it's very hard to go and to kind of like keep digging at the problem and kind of like, because you don't know if it's even solvable with the approach that you have done. I think good example is ChatGPT, right? I mean, kind of before it was released, we didn't have kind of anything like similar to that, right? Like we had different sort of chatbots before that, but they didn't feel natural, right? But after kind of OpenAI released it and kind of released some information about how they were doing it, I mean, alternatives start emerging, right? I mean, in a month, in a 2 month, right? I mean, because people kind of understood, kind of, okay, what's the small secret sauce that you had to put in it, right? I mean, or they could figure it out because it was instantly kind of like obvious. That's actually the thing. And that's kind of like the cost of doing research on the bleeding edge, because you will do all these mistakes, and somebody kind of will, and when you release it, somebody will understand, okay, that's the way how it's done, and essentially you are doing research and product management for them, because kind of they will go and kind of reap the benefits, and that's why we have the patents, right?
Mm-hmm. And how do you think of it? Like, did you have ever this moment that you did the research or something, and you understood that probably someone will copy it at some point, and now you do all this investment, and does it feel bad, and how do you think about it?
I think Bolt is currently kind of as a company is not on the level where we do kind of this bleeding edge of research. So kind of like we are not publishing that much. We are not kind of on this kind of say we are not big enough to pour the money in research because it's very expensive, as we discussed, right? Because like you just have to test a lot of hypotheses because something that will work. I mean, even Google kind of just pouring money in DeepMind without kind of a lot of kind of projects that they kind of like monetize out of it, right? But they have this capability. For us, it's not currently the case. We cannot kind of just go and do research for research sake, right? So in a sense, we are choosing very pragmatic approach in how we kind of pick the thing that we work on. And usually it makes sense kind of to concentrate more research effort on the things that are fundamental for your business, right? So let's say for Bolt, it might be everything related to kind of like pricing strategies. And kind of that's the thing that you also see that our competitors, like Uber, for example, they don't publish much about it because that's the secret sauce. That's the most important thing on the platform. But you see a lot of papers, even for Uber, how they describe like how they solve the customer support automation on their end. I mean, like they describe like the modeling approach, the things, because it's not the crucial thing. It's not kind of the secret sauce that runs this business. It's pretty easy for others kind of to figure out. But the secret sauce, that kind of like when you want to kind of focus your research efforts on, because kind of the payback there is the biggest.
Mm-hmm. Yep. I was thinking about this thing that probably, for example, Uber would build some new feature, ML-based something. Let's say they improve their customer support agent somehow. And then you would go and check out their customer support agent, and you would figure out that that's actually a nice thing to do. And before, no one did this thing. So kind of, in some sense, Uber did some work for you. And in the same way, you do some work that Uber in future can copycat as well.
Exactly.
So coming back to product management, you as ML engineer, or maybe as a ML team, what do you guys expect from your product manager? Do you expect some skills? Do you expect some information? Do you expect more like that they would understand what you talk about? These things.
I think like some familiarity kind of with the terminology that we use is certainly a plus, because it kind of just removes this hurdle for us kind of to explaining all the things from scratch. I particularly have been like very, very lucky to work with very, very awesome product managers who kind of know a lot of things, and like it's just pleasure to work with them because it kind of feels so natural. But I know kind of there are also examples where maybe like the collaboration doesn't work that well. What would I think expect the most is kind of like for product manager to have trust in the capabilities of the people in the team. So let's say if product manager is not an expert in, let's say, machine learning or data science, right, they should trust the experts that they have in the team, right? I mean, I'm not trying kind of to push like, okay, I read the paper around kind of that you should use Llama for that. Like, I mean, let's start deploying it, right? Because somebody somewhere wrote this, right? So in a sense, kind of having this natural level of trusting the experts in the team, I think that's kind of the basic thing that usually people, it's not only like machine learning engineers who expect things, the same to software engineers, right? I mean, kind of, and similar to designers, right? Designers wouldn't expect that I would come and teach them like what colors to pick in depth, right? So I think kind of this natural level of kind of trusting other people who do that they're able to do the job is kind of the first thing. Yeah, this thing that we discussed, like being good captain of the ship. So kind of like removing the obstacles when needed. So kind of, let's say maybe we are working on some model and we need some additional data that's not available in production. Kind of like, okay, how we figure out kind of like how to prioritize that the other team on whom we depend on this data will also kind of like consider kind of our priorities, so kind of like helping us maybe kind of to explain the needs of the team to other people. So being kind of this good partner for the team is like very, very important.
Before you also you shared the story how I think it was something like OpenAI just released the 4th version of GPT, and you as Bolt, you started thinking, what can we do with this model? I think it was like there was some product manager who built a demo of a chat. It was basically a demo version probably of Alfred.
Yeah.
Does it mean that you personally, or maybe you as Bolt, you guys expect that product managers can build the demo?
I don't think there's such expectation. It's just like, as I said, kind of, I was like very lucky, like working with this. That's actually a particular guy I meant, like, hey, Toby, just giving the kudos to the guy. I mean, like, he's really very competent on all sort of things. So I think it's not an expectation, but maybe kind of, especially in the moments where kind of such technological disruption happen, is kind of like very important for people who involved with this kind of getting to know technology. And you can't get to know it if you just read about it. You can like, you should at least use it, right? I mean, if you are capable of prototyping and doing some coding and doing some demo with it, I mean, all the best, especially considering like you could use GPT-4 to kind of write a demo to build a chatbot for GPT-4, right? I mean, that's kind of like a nice recursion going on right in there. But I don't think it's kind of like the necessary quality of the product manager, but kind of this open-mindedness kind of, and the ability to pick up kind of like what's important, kind of like when to focus on important things. That's, I think, certainly a requirement.
So we talked about the requirements, but maybe there's something you would like to recommend to product managers who aspire to go into machine learning or data science or AI, or to work with research heavy product management, product teams.
Yeah, I think like research heavy teams for product managers are pretty difficult, exactly because of all of the things that we discussed. It's kind of this huge amount of uncertainty. So I think patience is certainly like one thing I recommend, and maybe kind of reading up and kind of trying to understand kind of like all these challenges that kind of like those research-based endeavors have in them naturally. So you can't go and assume that kind of if somebody promised you like that there is a prototype in 2 weeks, then you can start deploying in week 3, right? It usually means that you will have some understanding of what's going on, or maybe not even that. So kind of like having this notion of how innovation works, I think, is the most important thing, because it's very naturally kind of transferable between different research areas, because it's kind of patient-based approach, right? As well as maybe kind of like on more like skill level is kind of having general feeling of technology, right? And that you can get only kind of by using a lot of different kind of like technological things, reading up on kind of like how different a disruption moment happened in the technology, right? Let's say emergence of internet, emergence of mobile phones. I mean, like the things that maybe like Elon Musk companies did, kind of like Tesla shaped the world, how SpaceX did it, right? So kind of like try to understand kind of like how the new technologies emerged, right? So then maybe it will be kind of easier to kind of find those types of moments, like even small moments in the your teamwork. I think like we had both had several moments like that when we kind of worked on the problem, and there was kind of this eureka moment, right? I mean, but if you describe the situation like that, everything started to make sense, and it's very obvious after you kind of figure it out. But before that, I mean, it's super difficult. So kind of like enabling those moments for the team is very important.
And so basically the main gist is PMs should be interested in technology. They should be, especially if they want to be on the cutting edge, they basically need to experiment with it themselves. Maybe not to be a PhD with a degree in this field, but at least to be interested. It's kind of interesting. How does your team, do you guys do any sort of research? Like, I heard that Bolt has like devotes 10% of their time to do just research, just to do fun projects, do some pet projects, or do something on the side. Like, do you devote maybe 10% of your time just purely to read the research papers, test out new models? Like there was Llama 3 and it was like a big thing, I heard. Do you do anything like that? Or it's just enough of research what you do as your main job?
Yeah, we don't have kind of this explicit kind of like time alignment where it's kind of like, okay, 10% time, you can just go and do research. So what we usually kind of like, how do we usually try to think about this is kind of like, if the research is important, the team has to kind of like defend it and make it explicit in the planning project, right? Like, okay, we actually think that, let's say, working or kind of experimenting with Llama is important for us, right? I mean, and we want to be explicit that, okay, that's part of the roadmap. So like we dedicate this time. So it's not kind of like, okay, you just have a placeholder and you do like whatever you like with this 10%. But it's like we want the teams to be explicitly like choosing kind of to spend this time on research, right? Because then it kind of creates this nature of kind of, okay, it's actually valuable for the product domain to go and learn about things. I think initially we kind of tried to kind of like had this time around when the team started, because exactly kind of to enable this exploration, like wide exploration, right? Because when you start, then a lot of things you can solve, right? I mean, so you might just kind of like to go in one direction, but is it the right direction, right? I mean, maybe like the other direction is much more fruitful in terms of kind of like impact, right? But let's say after you kind of explored a lot of areas, then it's much more clear like what are the roads that you need to pursue, right? So and then kind of like this dedicated time just to explore things around the main thing that you're focusing on, maybe not that relevant, but kind of researching inside the kind of like main thing that you develop is highly needed. So like to bring you an example, maybe kind of like 5 years ago, I could like use 10% of time to go and like work on how to apply autoencoder for fraud detection algorithms, right? I mean, like I wasn't even working on fraud, but it like was a nice idea. We went to explore it, right? Right now, I wouldn't spend kind of 10% of my time on this, but most likely, as you brought an example, kind of reading up on kind of how Llama works or reading on new methods of like retrieval augmented generation, that makes fully sense to dedicate my research time to.
Mm-hmm. And apparently there's a big fight on the internet or on Twitter, at least in my Twitter. Maybe my Twitter is special. People have fight what kind of models should you use? Should you use simply OpenAI API? Should you use a Hugging Face API? Should you use Anthropic? Should you do everything on-prem? Should you deploy your own models? Could you explain us how Bolt does everything? Do you use some API? Do you deploy something of your own? Do you build something your own? Or how do you do it?
Yeah, I think we kind of like covered it a bit in the previous section. Is like Bolt is very pragmatic company. So like when we do the choices, we think about kind of like what the impact this thing will have and what it costs us, right? So you're saying everything boils down to kind of this return of investment calculations, right? And so when you describe kind of the fights on Twitter and kind of like how to or where to deploy your say large language models, it's heavily dependent on the use case that you have, right? And let's say for the startup, right, if you don't even have kind of like paying users yet, right? I mean, you're searching for your product market fit. Why would you go and try to deploy your own model? Like you need people with specialized skills to kind of deploy large language models on some cloud infrastructure, right? I mean, like those people cost a lot of money. Instead of kind of like doing one API call to OpenAI, which I mean, everybody with kind of even basic coding skills can figure out, because I mean, you should focus on your product market fit, not on the fancy technology, right? But let's say on a company like which does like already have a lot of clients, right? I mean, kind of, and you do, I don't know, maybe millions of calls an hour, right? And then you start considering, okay, my OpenAI call costs me, I don't know, 10 cents. If I deploy the things on-prem, considering that, let's say, accuracy is maybe like slightly worse, but it costs me like 1 cent, then you kind of multiply by amount of calls that you make. I mean, and it's very clear kind of like which direction you should go, right? So it's in a sense very pragmatic approach, kind of like how to calculate like which route you should go. So I don't even understand kind of those type of discussion, because for each case, I mean, it's not that difficult kind of to understand kind of what should you do. I mean, okay, we can argue, let's say, oh, on OpenAI, like I say, on API level, I mean, should you go with Anthropic on OpenAI? But then again, you have your problem that you're trying to solve, right? And we haven't covered this in this talk, but I mean, on the meetup, I explained that the most important thing for us was when we're working with this customer support LLM-based automation was kind of how do we evaluate the success of these models, right? So kind of like running this sort of accuracy checks offline. So you probably have some data set on which you evaluate kind of what is the response of this LLM. Is it reasonable or not, right? And then it's like easy, like you send those requests to Anthropic, you send those requests on OpenAI, you say, okay, let's say Anthropic is like 10% better for my use case. I mean, you get this, you get the cost. I mean, you can do the math, like even like not in Google Sheets. I mean, it will be very, very apparent kind of what is the way you should go. So it's, for me, it's not even a discussion. It's pretty straightforward once you get the basics right.
Mm-hmm. But anyway, do you have a favorite model?
Favorite model. I think my favorite model will be gradient boosting trees. So it's not related to LLMs or anything. I don't know, like I think maybe all the audience of this podcast most likely haven't even heard about this, but that's one of the best way of solving tabular data type of problems. I think if we kind of sum up kind of the impact that is made by this models like across the world, like most likely it's much bigger, like just like really money wise than everything that neural network do, because most of the business problem that this type of, let's say, maybe boring tabular type of problems are not kind of like the fancy stuff that we usually like to talk about.
Yeah, I like this question because I expected some more general answer like Llama 3, GPT 3.5, GPT 4, something like that. And yeah, didn't expect it, must admit. And there was a story you shared before that you play D&D.
Yeah, happens.
I never played D&D, but I assume it's kind of like a role play. Yeah. And there is a master, and they read basically the plot of the story, and you kind of play this story. And you shared that you played D&D with ChatGPT when ChatGPT was just released.
Yeah.
And then you left us on a cliffhanger that if you want to learn how the game was, then come to me and talk to me. So can you please share, how was the game?
Yeah.
Do you like it?
So I actually played it when GPT-4 was released. I mean, GPT 3.5 was a bit still not intelligent enough, maybe kind of like to this type of interaction. But yeah, it was actually super fun initially because it felt kind of so naturally. And what GPT-4 really like, or this type of models like really success on, I mean, like they're very creative, right? I mean, so they can understand kind of natural language really well. So basically at some point, I think there was like some wizard that emerged, and like they had some chest, and they opened a chest and there was a riddle, and the riddle was written in the poemic form, right? I mean, it's not kind of simple riddle, it's like a specific riddle designed for this particular case for me. So it felt like very nice. But let's say where the thing got a bit boring is that like I think for everybody who communicated with this type of model, I mean, they try to please user, they try to kind of like respond to your questions even if they don't know the answer, right? I mean, so kind of like this pleasing type of behavior at some point kind of becomes very boring, because as a human beings, especially kind of in those entertainment like of scenarios, like we try to be like, we like to be challenged, like we want to explore new things, right? So it's not about kind of like always getting what we want, right? So like if my character wants to do something, like I want to like feel this pushback. So how it ended up, actually, like I became a villain. So my character actually became really bad and kind of tried to do a lot of evil things, because like then I tried to see how the GPT would react, and at some point I think I even kind of got banned because I used some things that weren't allowed on the platform. So it got dark pretty quickly, but it was pretty fun.
Mm-hmm. And how do you use ChatGPT other than just to play D&D? Anything else?
I think for me it completely replaced the Google search and kind of like the things that you search for. It's like usually if you want to let's say, I don't know, what's the difference between, I don't know, espresso and cafe crema, right? I mean, like, okay, you think, okay, I can imagine it, but I mean, I want to kind of understand what is exactly is the difference, right? I mean, then it's much easier kind of just to go ask on ChatGPT than try to get through like the Google search replies, right? Or you want to brainstorm something, right? I mean, picking some things for, let's say, your apartment, and then you have some ideas, and then you can ask ChatGPT, okay, critique them, right? And I might provide you some things you have thought on some things that you haven't considered, and so it creates kind of this kind of new direction where you can like think about things. And obviously, kind of I use it also a lot for my work, for my daily work. So, kind of as a research partner, kind of like just to dump ideas, kind of and just see how like what response do I get in terms of this. Also as a coding assistant. So I would say kind of like I use it daily, like pretty heavily.
And do you use actual ChatGPT, or do you use Perplexity, or do you use some other app?
For personal stuff, I use ChatGPT. For work stuff, it's ChatGPT plus Copilot.
Basically, there are many AI startups. For example, there are startups in customer support. You provide them the URL of your website, they scrape it, read your docs, and then they can answer any question you want, relatively. Do you have any thoughts about it? Did you think at Bolt to use any of these apps, startups, services, or in general, any opinion about it?
Yeah, I've seen several kind of startups kind of that emerge to kind of try to enable this customer support automations through the LLMs. So most likely they, most often than not, they are built on top of either OpenAI API or Anthropic API or whatever, right? I mean, kind of just provide this layer of kind of this automation management on your end. And they are geared, I think, more towards kind of smaller companies. So if you kind of look and investigate them, they have really nice interface how you can like drag drop boxes, right? So instead, like say no code solution, kind of like to enable your customer support automation. So in the sense, I think like they do this thing really well, right? So kind of this no code approach for, let's say, smaller companies to figure out kind of like how to automate support. In our case, we're already kind of like too big. We have a lot of processes that are not very easy kind of to solve through no code solution. So it would be very, very hard to integrate kind of such solution into kind of like our world. So for us, it makes sense kind of to build the things ourselves, as well as kind of, let's say, the thing that they are solving is not the thing that we need. I mean, we don't need no code solution, right? I mean, we need kind of like accurate system kind of on how to understand kind of what the customer needs and how to reply them, right? And in the sense, kind of intelligent there is not what they usually provide. We have much more competence on how to serve our users. So let's say we are a bit different markets than what they are targeting.
And before we were talking again about big companies doing 80% solved by heuristics, then other 80% by maybe a bit more sophisticated data team, and then machine learning, other 80% and 100. So maybe if for small teams, for small companies, it doesn't make sense to implement this, to actually go and use big data science teams. Maybe it makes sense for them to go and use these apps, services, etc. And one last question. I don't know how, if you want to answer it, maybe you don't, it's okay. How do you think will AI actually replace people? Will automation come in place of humans?
Of course.
What do you think about it?
I mean, absolutely. I think some jobs will disappear. It's very obvious. Like every kind of sort of automation was replacing people in the past, right? I mean, so when we started using like heavy machinery, right? I mean, you need much less people to go and dig the trench for you, right? I mean, kind of that already left some people out of the job. So the mostly question is kind of like, what is the percentage and what type of work will be replaced? And then this is like nobody knows yet. But I think for sure, like the simple type of mental work will be replaced. Simple type of creative work will be replaced. We already kind of see the AI or generative models, right? That I mean, that can draw pretty decently, kind of like very, very simple drawings that can create music, which doesn't sound very unnatural. So in a lot of kind of scenarios where, let's say, like the music, for example, is used for background, right? I mean, elevator music, right? I mean, that will be completely replaced by AI. I mean, are we really sad about it? I mean, like, is it like really big creative achievement, kind of like creating music for elevators? So in a sense, I think kind of those low-level creative work might disappear, as well as kind of low-level mental type of work. This for sure. When AI achieves level where it starts replacing kind of this higher level of creative and intelligent work, hard to tell. My bet is not happening in the near future.
Since this podcast is about product manager and it's a Tallinn product group, please subscribe and like this podcast. Big question: do you think AI will automate product manager jobs or role?
Not in the near future. So we are safe for some time. But, I think what it will help is that if product managers can use it as a helper and enhancer of their capabilities, that will make them much more productive, and they will be much less likely to be automated then.
That's a very good note to end this podcast. Thank you, Maksim. Where can people follow you, maybe reach out to you?
I'm not present in any social platforms. I think maybe keep an eyes open. Maybe next meetup that Bolt will organize, I will talk about something. So just come and talk to me. That's the easiest part.
Thank you for this podcast. Really, really glad to have you here.
Thanks a lot, Nick. Thanks a lot for having me.